This is Jim, W4JBM. I've got another project on the bench I wanted to talk a little bit about. This came from the estate of a local silent key, and trying basically at this point to decide if it's workable, and it's not. So the next question is it repairable? I'm having some issues there, and then just kind of from an interesting perspective, I thought I'd do a quick video just talking a little bit about it. It is a RF signal generator that was made by General Radio for the Navy. CAG 60006 is the model number, and it goes from 10 kilohertz up to 50 megahertz. This is serial number 63. The contract that they built it under was in January of 1939. Actually, the date accepted is October 5th, 1939, and the date placed in service actually isn't filled in. So if you look at this was down in a large square box, and it was recessed inside it. These standoffs, apparently there was some kind of lid that went over the top of it, and you were able to screw it down using the four of those, one in each corner. It didn't have the lid. There was in the case itself, though. Just trying to figure out one other thing that's kind of interesting. You actually see this on quite a bit of a gear from around this time. It says it's built under patents of AT&T. It's for use in research, investigation, measurement, testing, instruction, development work, and pure and applied sciences. I assume a lot of that, the reason those plates are there is because a lot of this was licensed for use as we approached the Second World War, and AT&T didn't want some of the patents that they were letting other people use as part of the war effort be used to compete against them later on. So just looking at the front panel here, kind of the basics of how this seems to work. I guess the first thing you would have to do is apply power, and there's a power connector down here. Actually the outer box references a power supply that's not with it, and doesn't give any specifications for that, so I'm not sure what the voltages actually are. You've got the main power on, and then the plate can either be on or off. That's nothing unusual in instruments, because you might want to leave the heaters on, turn the plate off, basically power the instrument off, but leave it warming so that you don't have to wait for it to warm up, which helps with stability, and also how quickly you can actually get to work on things. So the first thing you'd typically do with something is select the frequency. This is in several bands. This feels, I haven't looked into it yet, but it feels like there's probably a torrent behind it, kind of like the old television switches, and it goes all the way around, which makes me think that's probably the approach that was used too. But it's got bands A through H, and it basically starts at 9.5 kilohertz. You'll notice the bands are in increments of 10x, basically. When I look at band A, it's 9.5 to 30. Band C is 10 times that, 95 to 300. E is 950 to 3 megahertz. And then H is actually kind of an oddball, 30 to 50. But the other bands, like 30 to 95, 300 to 950. So I'd pick the band first. I wanted to go to just picking a number, say 1 megahertz. So now I've got you can see the pointer there, is the E band. Then over here is the main dial, and for A, C, and E, there's a dial. The same scale is used. B, D, and F, the same scale is used, again, because they're related by our power 10. G seems to be this outer scale. Doesn't seem to be a scale for H, which is the 30 to 50 megahertz band. Also, you can tell that the pointer's in pretty rough shape there. And then there's the more precision tuning down here. It's a reduction drive, but says that 1 small division equals 0.1% of the frequency change. between division 25 and 275 of the main scale. So this would let you get fairly precise frequency setting. So then the next step would be to actually set the output level. Sorry for all the focusing. My camera doesn't really like some of this close-in stuff. It may not like. You can get that. So the meter here in the middle can be used for two things. There's carrier and modulation. Normally you'd probably set it to carrier first and use this carrier adjust. You can see that there's a carrier set at the middle of the dial. So that's where you would make the adjustment until the meter read that. Then if you were going to modulate it, modulation, you have three options. You can have the modulation off. You can use the internal modulation. I don't know what frequency that's at, probably something around 400, maybe as high as one kilohertz, or you can use external modulation. But if you went with the either external or internal, you'd set the modulation percent by changing the meter over. Now you could read this bottom scale and adjust the modulation percent to where you wanted it to be. You probably would, I'm guessing, have to go back and forth a little bit just to make sure that as you modulated the signal, the carrier didn't change level. Sometimes there's a little bit of interaction. You might have to fine-tune that just a little bit. Over here is where the external modulation went in, a pair of banana plugs. Then the output, so there's two outputs. One is this constant 1 volt output. So this is, if you had used this the center, the meter to set the carrier, you should have 1 volt, probably 1 volt RMS coming out of there. And then there's a second output down here. And if you look at how this is adjusted, there's a MicroVolts dial, and that goes from starts at 10 on the high side, goes all the way around to 1, but then there's also settings for 0.5 and 0, and then there's a multiplier over here. So if I set this to say 5, so there's 5 microvolts, I could set the multiplier to where's the pointer? Okay, there. So here I've set it to, the multiplier is 100, so I've got 5 times 100 or 500 microvolts coming out of here. And I can go all the way up to multiplying times 100,000. So at 10 times 100,000, that basically is going to give me the full 1 volt that I had up here, out down here. And then when I go to a multiplier of 1, that means I could actually get down to as low as 1 microvolt output. It does talk about, so there's the outer box lists 4 components. This is the main part is this the oscillator itself. There is the power supply, and there's no specification on the power supply. It does say it's powered by 115, 120, 60 hertz to 400 hertz. So kind of a standard. The power supply was apparently made for not for shipboard use probably. And it also talks about that there's a dummy antenna. Actually, dummy antennas are something that are probably worthy of their own video. A lot of people, when you talk about dummy antennas, they think dummy loads. But dummy antennas were typically used to, between something like this, a signal generator, and the radio, or like a receiver, so that this more accurately reflected as you were trying to tweak like the front end or something. The radio thought it was seeing an antenna, and the adjustments you made would hold even once you disconnect it from this unit and connect it to an antenna. Because at this point in time, something like the standard 50 ohm output was not the norm. So the dummy antenna actually had a frequency response that was similar a lot of times to something like a long wire antenna. It also says that there was a fixed 10-to-1 attenuator. I don't know if that's this device or not. This doesn't have any kind of marking. These are kind of an unusual jack. It's actually not that unusual in test equipment at the time, but you don't see them much today. I believe this is just a standard, like a banana plug in the middle, and This goes down and fits inside there and plugs in. It can go into either one of them. So not something that you run in today. These, like if this is the 10-to-1 attenuator, this actually has a BNC output. So and actually the other one does too, which would let you hook it to something a little more common, a little more normal. So anyway, I'm going to go through. I'll talk a little bit about some of the different sections of this as I look at them, and share that, and then at some point we'll talk about where we go from there.